Hello, this is Dan Alford, and you're listening to Dan's Cadre of Experts. We have another welding engineer on today, Nathan Sumrall. Welcome to the show.
Thank you so much, Dan. I appreciate it. Thank you for having me out here.
All right, so I've known you, 8 years? How long?
9, actually.
9 years, okay.
That's right. That would have been January 2014 is when we first met.
Right. You've had one job since you graduated from LeTourneau.
Yes, that is correct.
Okay. And who interviewed you?
You did. You interviewed me for my job.
This is a fun story. Well, more fun for me than you probably, but
I felt real small.
No, don't ruin it. But so way back, Bill had decided to start a cladding company. Your current boss.
That's right.
And so he said, Dan, I need a welding engineer. He says, but I don't even know what questions to ask. So you interview him. So I interviewed you. It went pretty well. I said, obviously you were educated in the system, but what I had to tell you, I had to break it to you that this was not an entry-level position, and as a fresh graduate, you were not qualified.
That is very much correct. And I remember on the phone call afterwards, I was getting ready to fly back to where I was living. I lived in Dallas at the time. And I remember Dan distinctly saying that you're not ready for the job, but you're ready to learn, and that's the kind of person that needs to be in this job.
Yeah, and so it all worked out.
Yeah. I mean, a lot of guys in our field and profession idolize something that we call the tenure, the job that they do for 10 years, and I'm 9 years into that. I think I'm doing pretty okay so far in that regard.
Yeah, it was nothing against you, nothing against LeTourneau, but this is a tough job because you're going to be a one-man welding engineer army. You needed to understand the metallurgy of Inconel alloys, which is not common knowledge. You're having to work to NACE, which is a tough spec. And you were building really critical parts that if you guys screwed it up, there were oil spills and potential fatalities and all sorts of stuff. And so, but what we did, I think we had you work with Dave Hebel and Dick Holdren, and now at this point, I think there are few people that are more expert in the field of corrosion-resistant gas tungsten arc alloy welding than yourself.
I really appreciate that. That is very kind. To start from knowing nothing to knowing how much I don't know, it's a process of just continuously learning and also just asking, why do we do that, and is there a better way to do it? And what's really cool about hot wire TIG, this idea of preheating wire before you feed it into the arc, you can do so many things with it that a lot of other welding processes are limited by. And the fact that I got to start into that kind of major process, graduating right out of college, really set the groundwork for all of my future work. Even though I do qualify procedures with sub-arc welding from time to time.
Gas metal arc,
flux core, just basic TIG and stuff. Everything pays homage back to the hot wire TIG.
Start with the hard stuff and the rest of it looks easy.
Exactly, yeah. And when you start out with that methodology, it makes everything else a lot easier to actually execute because you're already used to the hard stuff. So right now, I'm qualifying a welding procedure where we have one procedure coupon qualifying 5 welding procedures at the same time.
Excellent.
Yes, and you're seeing cladding on different base metals, on different alloys,
different
butters, thicknesses, closure
Is it
welding.
A strength weld too?
Oh yeah.
See, so you're qualifying both as a strength and an overlay.
Yes.
Excellent.
And even more so, just challenging the old adage of, if you have a custom-made wire, do you have to use it all the time? No. What if there's an industry available alloy that can do it better that a lot of people make? That's something that's very useful to think about.
Okay, let's talk about the reason I like TIG. I guess is the same thing. You have independent control of heat, travel speed, wire feed speed, and now with hot wire, you have the ability to change filler metal input temperature. So so I guess I'm with you. It's a great process. You have total control over all your variables, and they're independent of each other. Back up though.
Sure.
What is the point of this exercise? Explain sour service, H2S, stress corrosion cracking. You have 2 minutes. No, go ahead.
I mean, the elevator speech is fine. You know that rotten egg smell over at Yellowstone?
Indeed.
Yeah, that is indicative of hydrogen sulfide or H2S. That gas eats steels for breakfast, and as oil and gas has been producing material over time, we've been learning about how it impacts other alloys too, including the Inconels that we've already talked about. The biggest challenge anytime that you have H2S is, do you have a material that is under a lot of load, as in being pulled apart, tension, stresses? Is it being exposed to a lot of hydrogen and sulfide or sulfur or a combination thereof? How is that acidity, that pH level, if you think about it? And last but certainly not least, a metal that is really prone to sucking it in and keeping it in there and letting those pockets of hydrogen burst like balloons within. Whenever you have that susceptible microstructure, a lot of hydrogen nearby, and a tension stress that is just pulling in the right direction, you can have a lot of failures that can result from a different combination of mechanisms thereof.
But does it have to be atomic hydrogen?
No.
It can be H2.
Yes.
Okay. Well, then why aren't 4130 compressed gas cylinders susceptible then? They're under stress. It's a susceptible material, and you have H2. No one's explained that to my satisfaction.
I don't think I can either.
Okay. But in our world, the H2S is actually a byproduct from microbes beneath the surface of the earth that are eating the oil, and the byproduct is H2S. That's the sour gas you get in oil. You know, everybody talks about sweet crude and then sour crude. Most of the oil that's left now is sour, from what I understand.
There's a decent amount that's still sweet that we are finding. So there's plenty of exploration into the CO2 side of things, not just H2S.
So the same corrosion resistance alloys will solve the CO2 problem as well as the
Correct.
H2S.
Yes, but what's kind of interesting about that is the criticality is so much less severe because, you know, it's sweet to your tongue. It erodes your teeth over time rather than in the first hour of use, right? So the same thing applies to alloys downhole. So where a lot of people look at your super alloys like your Inconels, they want to have super low dilution whenever it's being exposed to hydrogen sulfide. When it comes to CO2, they're okay with a much higher threshold because there's a lot of industry specifications that don't provide a rigorous criteria for it already. Like we've made reference to NACE already. NACE MR0175 is the subsea H2S specification.
National Association of Corrosion Engineers.
Yes, and now it's international.
Right.
International, national.
People still call it NACE.
Right.
All right, and so and that's the problem. You start talking about dilution. The most common metal used for piping and valves and such is iron-based, which is steel, and it just so happens that's what's most susceptible to sour gas. And so when you're worried about dilution, it's because as we weld, we pick up some of that base metal, we mix it in with whatever alloy we're applying, and if it gets beyond, in NACE's opinion, 5%, it's excessive. 5% iron, that's excessive.
Right, and even specifications like API 6A have a higher criteria of 10% iron.
Oh, okay.
And practically, it could be a lot higher than that. I know of some guys that have done research that have pushed upwards of 30% iron content and not dealt with any type of failure mechanism that NACE summarizes in their specifications. But a lot of people don't want to try that because the specification has been so rigorously established already. Everyone's used to 5% iron. Everyone's used to 10% iron.
And we've had such good results in the field. I had Dr. Robardo on recently, and Charlie says 20-year life is common, and with this inlay. Okay, well, I guess, I don't know, have we been clear that, so the point of this exercise is to reach inside all these valves and pipes and fittings and apply a welded coating to all these complex internal surfaces. And that coating is typically Inconel, which is chromium nickel, which
Yes.
is relatively immune to the H2S.
That's right. Now, with different alloys of Inconel, you can have some susceptibility to hydrogen, but that really depends upon the surrounding environment rather than the product flowing through the pipe itself. One of the
Right. It's not always from the H2S that we get the hydrogen problem, is it?
Correct. Cathodic protection is probably one of the main failure mechanisms that plagues Inconel, both weldments and products in the field. For example, Inconel bolts made out of, like, let's say alloy 718, those are extremely susceptible to be charged with so much hydrogen that they'll just snap in the field.
Right.
A good example of that would have been the Katami flow line issues in the Gulf back in 2020. There were a lot of bolt failures there that were made out of 718, and just because they were near a zinc galvanizing almost like cathode or anode for long enough that they just popped apart.
Same thing on the Thunder Horse failure. That was a cathodic protection, but that actually affected a weld.
Correct. And I was thinking about the Thunder Horse one because that was around the time when NACE really started considering a new hardness criteria.
I agree with you completely. So when they
Yes.
went from Rockwell, the larger Rockwell C indenter, to Vickers
Vickers.
indenter,
Uh-huh.
industry reacted by changing our post-well stress relief to a much longer, it's virtually a subcritical anneal now, in my opinion.
Yeah.
And that caused the chrome carbide layer.
Yes. So to give people some more background, what Dan and I are talking about is solid state diffusion, as in atoms moving from one interface to another when they are exposed to stress and time. And what's really cool about that is you can actually make alloys do very specific things, and unfortunately they can do some very specific things to you. So in the case of where you have Inconel touching another material, if you have it heat treated for a long enough time, it can take that chromium and put it right at that interface where Inconel touches base metal, the fusion line, and with enough time
And enough carbon in the base metal,
Yeah.
in the steel.
and then enough exposure to your cathodic protection in the field, this entire weld goes.
Yeah, you have to do a bunch of things to make it fail. But the good thing, the industry learned a bunch from Thunder Horse. No oil was spilled. No one was harmed.
Yes, and there were some accidents later that could have been prevented if those.
We'd learned the lesson better.
Exactly. Yes.
Well, I've got a great book on oil field corrosion, and there's a page which speaks to this. But sometimes you have to relearn lessons.
Isn't it known as like the $20 billion page or something like that?
Yeah, that one's expensive.
Yeah. That's how much money you would save if you've actually read it. Yeah.
But that's the exception. There's thousands of these valves and things and Christmas trees running,
Yes.
with zero problems. They're so reliable that you can't inspect them because they're at the bottom of the ocean floor in some cases. And so we've really had a lot of good success in the industry.
So much so that we are applying the solution in other places where it's not been explored before. For example, a lot of Inconel cladding is now being done topside on the surface on the production side of things. So we welded a structure recently that it was originally a carbon steel structure and it lasted for 60 years. Since they were having to replace that whole section of piping anyway, they said, why don't we just clad the entire thing with Inconel? And someone asked, so how long is the service life? They said, well, the carbon steel lasted 60 years, so how many centuries or millennia are we talking here? Yeah. That was the practical benefit of lining inside with this. And there are a few situations where the designers completely ignored H2S, and I would like to bring up Kashagan.
Where was that?
That was in the Caspian Sea over by Kazakhstan.
I think I've seen photographs of that.
Yeah, so this was a man-made set of islands in the Caspian Sea that, it took them around 10 to 13 years to actually develop and design everything and then build it. And when they turned the pumps on in 2014, almost the entire structure had severe H2S corrosion issues within a month.
Wow.
As in, every single area that you could think have had a major leak and it was all H2S.
Was it unprotected steel pipe? Mm-hmm. Okay.
And it was also steel pipe that was probably not made for H2S. And that makes it all the worse, because if you have a formed material that is really not suitable for it, it just gets worse and worse and worse. For example, when you take a rolled plate and weld it down the middle,
Yeah.
you can have those linear disbondment issues just within the base metal itself, and that becomes a big failure mechanism for H2S later on. NACE even recommends seamless pipe wherever possible for that reason alone.
I mean, I've noticed we typically will clad seamless pipe. I didn't know what the motivation was.
The more clad, the better, right?
Mm-hmm.
Well, unless you clad in the wrong spot.
Yeah, you can. We've started to use Inconel on some rock bits, and it's interesting. It's caused the corrosion to be focused on other areas. Yeah.
Yes, and having, it's almost like the Inconel itself is the cathodic protection now that's making localized corrosion happen in the other steels. So one of the old adages of oil and gas is whenever you have a cladded system, you have to closure weld it with Inconel as well. Otherwise, how do you make that closure weld? You got Inconel on the inside of it. Mm-hmm. How do you do that with anything but Inconel? Oh, there's some ways to do that, and that's where refinery guys are pretty smart. There is another corrosion specification called NACE MRO 103, and that one pays homage to the idea of welding your components separately with clad, closure welding them together, and then back cladding every unit at the end of those major operations. If people are familiar with API RP 582, that is a recommended practice that also references back cladding and how you would go in and clad that little 2-inch section afterwards. Yeah, we're exploring with that with Subsea now. We're looking at that as a way to make sure there's no Inconel on the outside of a structure that can make the surrounding steel corrode faster.
And the reason you don't make everything out of Inconel is because it's 10 times as expensive as steel, and there's strength issues.
Yes.
You simply can't make it as strong as a high-strength, low-alloy steel.
Yes, and anytime that you try to push the strength of Inconels, there's almost this... oh, shoot, I just drew a blank. Who was the...
Sam?
Not Sam, no. I'm talking about Greek gods, guys flying too close to the sun... wax, wings, melting
Icarus.
falls. Icarus, okay, yeah. So we have an Icarus problem with Inconel. Like, our Inconel, we can get it oh so strong, and then we try to push it a tiny bit more, and then stuff just falls apart.
Mm-hmm. Our mutual friend Sam Kaiser, he's working on some high-strength alloys as we speak, trying to address this exact problem. But currently in our world, it's all 625, and it's interesting. I've been working in submarines lately. Guess what the alloy of choice is for marine water contact or seawater contact?
The Inconel 625 again?
Same. Yeah.
Yeah.
So it's been a good business for me and you. I build the machines, you run them.
That's right, and I try to buy more machines whenever I can.
Oh, bless you. But we got some history outside of work too, don't we?
We do. We have some quarrels yet to settle as well.
Oh, yeah. So I had the guy on from GOA recently, and we talked about all the different shooting sports, and one of them I mentioned then was the running guns, which is like a, what do we call it, a center fire biathlon.
Yeah, so you know how the Olympics uses 22 rim fires? This is the little more kapow version, right?
5.56 rifles and 9mm pistols, but you got to run 6 miles and then shoot between 3 yards and 300.
Yeah.
What was the last one we did in Waco? That might have been
a 500-yarder.
500 yards.
Yeah, and my gun had a way too short of a barrel and couldn't even reach out there. So I learned a lot at that event, and that's the event where you whooped
so I
my
beat
butt.
you soundly at that event. But then,
very soundly.
But then you got revenge later on in a team event.
That's right. I got the best man from my wedding to commit to good cardio and carrying around an extra 20 or 30 pounds worth of weight on top of his gear. And he and I were sharing that stuff back and forth. and getting our cardio in so we could run these miles and outshoot you at the same
And
time.
my daughter.
Yes.
And that's
So we beat both of you guys fair and square that day.
okay. So we it sounds like we need a rematch to settle this.
Well, we do need that rematch, but then there's also the debate of the guns we use, because you're an AR guy, and I'm kind of an AK guy.
You brought the wrong gun.
But man, I beat you.
And on the second
Yeah,
one. Second
the
one.
first one I brought an AR, and you beat me.
Okay, head to head, then
That's right.
maybe I need an AK.
I mean, I got another AR, so we can make it even that way.
What's your latest your latest one? Because it's been fun watching you put this thing together. You took a perfectly good Toyota pickup truck.
Yeah, Toyota 4Runner specifically, yes.
4Runner, okay.
Yep, and turned it into a race truck.
There's no windshield.
It is there, and it is removable, and it is still street legal.
But once you get on the racetrack, you're not allowed to run a windshield, right?
No.
So what is this thing all about? Explain it.
Sure. So off-road racing is a very nuanced form of mayhem and pain for the racing community. A lot of times when you want to go racing, like let's say you go down to MSR or something like that, is a designated track.
Which is a asphalt paved track.
Yeah, and you go around all of the corners and the curves, and you brake at the same time as everybody else, and you accelerate the same.
Fun.
Great fun. You know what? Even though it's an expensive hobby, it's still pretty cheap. When you want to go out in the desert and do that with little to no warning, to not knowing where you are, to making sure everyone's where you need them to 1,000 miles down the road, that is a order of magnitude.
So a
more
great example is the Baja 1000, where
That
you
is
start in
correct.
Ensenada and you drive down the length of the peninsula
to La Paz.
to La Paz.
Yes.
1,000 miles later.
Yeah, and it's typically 1,000 miles in a straight line. You might be doing 1,200 or 1,400 miles. You're lucky if it's an 800-mile year, but this year is definitely not that. And rumor has it, they kind of hide the race course before the
Right. They don't
before it
publish
happens.
it. You get to pre-drive it for a week beforehand, though.
Exactly, even 2 weeks if you're lucky. And that pre-running really does make or break a team. And we're building a race truck to do just that, to go down and finish the Baja 1000. I would love to say win, but the attrition rate is so bad that if you finish, you've already beat half the pack, right?
Finisher's pin is a treasured thing. I've got one
That's-
out of my 2 attempts.
That is a precious thing. And the fact that you've already done it has been a great inspiration. And I've had the chance.
Yeah, but I did it on a bike because our tire bill was half of yours.
I believe it because, I'm going to a racing event April 22nd, and I'm bringing all the spares I have, and I know that it's a pittance compared to the spares I'm going to need down in Mexico. Mm-hmm. So this off-road racing thing has been a dream of mine ever since I was a kid. I grew up watching Ivan Stewart and his Toyota mid-engine spec trophy truck and him flying through the desert. And I got to see that vehicle in person in February. I went to King of the Hammers. I got one of my buddies here in town races in the Everyman Challenge with his own Ultra 4 buggy. And while I was there watching him, I turn around and look at the Toyota booth, and there's Ivan Stewart's beloved truck. My dream come true.
Is it still running?
I don't know if it's running, but it's definitely rolling.
Rolling, okay.
Yeah, so they have it in Plano most of the time at the headquarters in their museum area, whatever that is. But they take it out to big events, and they took it out to King of the Hammers. So I physically got to see it, get underneath it, take photos of everything that I wanted to learn about. That was a dream come true, and all the more fire to complete my own truck to race the same races he did.
Okay, other than knocking out the windshield.
Other than knocking out the windshield, welding, or is rather than knocking out the windshield, think of it this way: you have to make a vehicle meet the race requirements, and the rule book is thick for off-road racing. Score
Not
is,
for motorcycles. It's a whole lot easier.
Yeah, the
Just so
motorcycle
you know.
section's like 3 pages
Yeah,
rather than
they
30.
assume we're crazy and they don't care.
Exactly. And you guys are. You really are crazy, and that's okay. We love you for it. So,
But y'all have to be safe.
safer.
And so you got full roll cage. You spent a year building this cage, right? And you did it
2
yourself.
years, actually,
so you're one of those rare welding engineers that actually weld.
Yeah, I took 3 weeks to make sure I would qualify 6GR correctly with bends and everything before I touched my roll cage. And the roll cage was hard. I have over 600 hours worth of work into that cage alone. And then you have the whole fuel cell and safety system that's in place. You have the long travel suspension that's already in there. You have the windshield setup we were talking about.
You have radios?
Racing comms.
You running a radio?
Yeah. I have a ham radio that works with all the racing frequencies already. And I'm already a ham operator, so that makes it really easy to start off with. But navigation is a big deal. The new Garmin navigation setup is awesome.
Because you're driving in the dust. A lot of times you guys have zero visibility.
Right. So your navigator is telling you turn left, turn right, turn left, turn right. Hey, there's a cliff there. Don't go. Oh, we went that way.
Oh,
Great.
fun story that, some of the fast truck drivers warned us. They said, you guys on the bikes don't go back out in the cloud of dust because we're driving without visibility, and occasionally you won't see the bikes.
Yeah, and the bikes become speed bumps. Yes.
We hate that.
Very much so. I would not want to be a speed bump either.
So, but maybe that roll cage will save your life. There's a lot of rollovers in these races.
There are a lot of rollovers, and I took so much time to make sure that you would have a good, easy ingress and getting out of the track.
On road racing, they time us.
They do. At contingency, they make sure that you can get in and out within a certain time frame, and you have all of your supplies there. You have to have 2 to 3 days worth of food and water with you, major first aid equipment.
See, they didn't ask us to do any of that.
Right. Extra satellite navigation, extra satellite communications, and the one thing I think that a lot of racers forget is the navigator. They're in the roller coaster of their life, and they're just trying to hang on. So their arms are holding onto the roll cage up here, and that's the spot that gets crushed first in a rollover. So over the last couple of weeks, I was even designing a whole handlebar setup that they can hold on to.
Good idea.
While pressing the navigation buttons and radio buttons, so they can always have a secure purchase. And then also telescoping in and out, that's something no one does with the navigation. So my guys can get really comfy in there just right and then do their work.
But they've got a 6-point harness to keep them from hitting it.
5-point, but yes.
5-point. I recommend 6.
A 6-point really does protect the junk a lot better than a 5-point, right? But the way I have it set up right now, it's just a 5.
Well, everybody's got different priorities. I prefer a 6-point.
That's true. You have more kids than I do. That's true.
All right. So I heard to make a small fortune in racing, you start with a large one.
Yeah. So if you want to win $1 million, you got to spend $100 million. We're definitely on a budget with this one. To give you some background, I saved about $50,000 by doing the cage myself. I spent the amount of money in my steel in most people's scrap making their roll cages. So I really took a good amount of time making sure that was set up right.
You taking sponsors?
Yes, I am taking sponsors.
Here's your chance to sponsor a desert race truck.
Yeah. So,
do you have a website? Did you build a website yet?
No, I have a Facebook group, but that's about it. So we're in the process.
How do you find it?
Look on Instagram, YouTube, and on Facebook for Good Mayhem Racing. That's where you can keep track of all the stuff that I'm doing with this 4Runner and everyone else that's involved. And
Good Mayhem.
Yep, Good Mayhem. That's right. And that name came from my previous run and gun kind of stuff where I did a lot of force on force training with friends. And there was one mission set where it was me and another guy, and we held up an entire platoon of dudes from moving forward because they thought they were getting flanked by a huge army, and we were just bouncing from barricade to barricade.
Mayhem's your friend.
That's right, especially if it's good mayhem. That's right.
Okay.
Yeah.
So when's your first race?
April 22nd. It's going to be at the Rally Ready Driving School in Austin. That one is a TORE tour event.
Yeah.
The next one that we want to do, pending the truck survives the first one, is the Texas Desert Racing Association stuff that's happening in El Paso, the May 26th weekend. No, I think I got that wrong. The Southwest Texas Desert Racing, something like that. Yeah. That's May 6th. And then after that, who knows? We're prepping for Baja at that point.
How many sets of wheels you got?
Not enough. I have 2 complete sets, and I need like 4.
Yeah, absolutely. You gonna carry brakes?
I'm going to carry as many spare parts as I can.
Good idea.
Brakes, alternators, axles, CV axles. I got too many axles on the truck. I'm in a 4-wheel drive vehicle. Oh, that's very uncommon in Baja is 4-wheel drive vehicles. Most of them are 2-wheel drive. So
I can remember some places where that would have been extremely beneficial, though.
Exactly. And rather than going fast and getting stuck, I'd rather go slow and not get stuck.
You know, it's been a while. It was '08 when I was running the 500 solo and didn't finish, but we won't talk about that. But I went through some water that was 38 inches deep. Can you handle that deep?
Yes.
You better.
My record water crossing in another vehicle I used to own, an FJ Cruiser, was 54 inches deep, and that was during Harvey.
Okay, good. Well, as long as you're prepared. I was kind of surprised when the motorcycle got quiet because the exhaust went underwater, but it kept running. And
yeah, you know those snorkel things that are on some cars?
I didn't get one of those.
I have one of those in this truck, so that helps out a lot. And then also, once you can get all of the drains and all of the breather lines,
you better get them up.
Yeah, get them up, get them wrapped. Yeah, we're doing all that kind of stuff with this truck.
Interesting. All right. Well, to pay your bills, you got to go back. You got a day job, and you're working with Superior Clad.
Yep, that's right.
And so, in case there's somebody out there trying to figure out what career, for you and me, welding has been very, very good to us. Now, I don't have a welding engineering degree like you have. Where'd you go? Tell us the story.
I went to LaTourneau University,
Longview, Texas.
Mm-hmm. And
started by a fellow named R.G. LeTourneau.
Yep.
My favorite LeTourneau quote is, "There are no big jobs, only small machines." R.G. used to build some of the largest machines on the planet.
Yeah, that he did, and they were giant earth movers.
And they were all welded together,
Mm-hmm.
and he couldn't find enough welding engineers.
Nope.
So he made them himself.
That, and also he made a lot of special alloys that people would scratch their heads at years later.
Mm-hmm.
They're like, this is really close to 8630.
But not quite.
Not quite.
So how'd you pick LeTourneau? Why LeTourneau?
Sure. I grew up wanting to be an engineer, good old customary Lego story.
Mm-hmm.
But I didn't know what kind of engineering I wanted to do. I was kind of stuck between mechanical or aeronautical and some other heathenous engineering discipline.
Mm-hmm.
And in my freshman year of high school, I was spending time with my sister, who was also going to LeTourneau, but for biology. She looked at me and said, "Nathan, LeTourneau has an engineering degree that's crazy enough for you." And I said, "What's that?" She said, "Welding engineering." And I said, "That's a great idea. Let's go blow something up." So we shot potato guns and had a great time. So
interesting. Well, I was talking to Dr. Robardo, and he said, there's probably less than 50 welding engineering graduates per year. And so you guys are in short supply and high demand.
That is correct. And there's about a 90% attrition rate at LeTourneau when I graduated. I hope it's a lot better now.
Wow.
Yeah, so
a lot of business majors.
Business major conversions. Yeah, so we started out with around 40 people or so in my graduate degree, and it's a formal bachelor's of science and engineering, not an engineering technology. Even though they do have that program there, and plenty of my counterparts in the industry have that. They're great guys. But yeah, we had 40 guys start, and we only had 4 graduate on time, and then 2 graduate like 2 years later.
Wow.
And I was even a 4.5-year baby, so.
Okay. It happens.
It happens, and when I graduated, I still knew nothing.
Well, you knew enough to con me into agreeing to.
Into learning how to learn. That's right.
No, it worked out well. It all went good. So what do you think of the other schools, just in case there's... so I've actually, we've endowed a scholarship at LeTourneau, so I'm a big fan, obviously. Some of my professors who had the most impact on me were trained at LeTourneau, so I'm a fan. But there's Ohio State, there's Ferris, you got any comments?
I think that the biggest question is if the engineering can put a weld to plate and walk the talk, they're worth their salt.
All the schools do a good job.
Yeah, and if they're doing a good job of that, I can't fault them for it.
And A&M has a good, it's a technical program, but
Yes.
they've got that. So.
And the technical program is usually also done in parallel with the main engineering discipline that they're doing. So I know some mechanical engineering techs that came out of A&M that did their whole welding discipline at the same time, and they are phenomenal welding engineers.
But as I recall, Texas doesn't even recognize welding engineering on their professional testing. Is that correct?
You're correct. So if I want to get a professional engineering,
You have to become mechanical.
a mechanical or something else,
Right.
right? Heaven forbid electrical, but I mean that's a black magic territory that
So
I
that
just
it is.
kinda bow to.
The point is, it's a small field. So
It's a small field, but as welding engineers, the sign-off authority is already there, where with a lot of other engineering disciplines, it's not. Usually the PE is going to be signing off on top of anything else that the other engineers' designs are doing. With welding engineers, it's kind of that stop, and you kind of go to doctorate from there.
Yep.
So it's Bachelor's of Science, a useless Master's of Science, and
Don't be
then
mean.
okay, and then a doctorate from there.
Yep. Like Charlie's.
Yes.
So, but yes, so you're the guy signing these welding procedures.
Yes, and qualifying them and figuring out the science, and a lot of times trying to evaluate the risk for clients. Yes.
If you had it all to do over again, would you do it?
Yeah.
Yeah, it's been good for me too.
I mean, it's been great, and when push comes to shove, everything that I've been learning for work has been a direct benefit for the things that I want to do, right?
Right.
You know, like we were talking about our hobbies, guns are and everything that's around that freedom stuff revolves around complex material interactions with pressure, right?
Yep.
And welding fits right into that. Welding fits right into the fabrication and manufacture of cars, especially with auto racing, where you have to figure out how to triangulate everything you can think of. And welding, I mean, there's so much criticality around what I do in my profession that the mindset also goes into my day-to-day life. And
Good.
I really try to love people through that. And even being married, I love my wife, and she has been a wonderful, wonderful, patient.
She amazes me.
Yes, she's an incredible woman that both lets me do this kind of stuff
It encourages you.
It encourages me to do it. She's like, yeah, you're going racing. Yeah, like when we went to King of the Hammers, she looked at me and said, happy early birthday, go get all of your racing safety equipment. So like my neck restraint, my helmet, some other critical like
I'm
Honda
alive
stuff.
today because of a Hans device, so I'm a huge fan.
Yeah, they are incredible. They really are. And my wife is saying yes at the right time. You know, it's not like we're gonna go into debt over this hobby. We are really making sure that we are doing it right within a budget, and she is the cornerstone of making that happen.
Yep, that's good, because at some point you got to retire.
Yes, that's right.
All right, well, then good luck on your race. I hope you don't test your roll cage. We'll have to get you back and give us a full report.
I hope I don't have to either, but you know what? If the vehicle dies but everyone's okay, it did its job.
Yeah.
It's
It's just stuff.
It's just stuff. And even if it's got a lot of sentimental value like this one does, it's still okay. Like my parents, they bought it when I was 8 years old. I grew up with it. It's got 280,000 miles on it. And shoot, it'd be great if we actually completed the Baja 1000 and got to 300,000 miles at the same time. That would be really funny. I don't think almost any other race car's ever done that for that race. But it's okay if it doesn't make it, so long as everyone else is okay.
Yep, I remember staring at my Formula V car hanging on a hook at Texas Motor Speedway in Dallas. It was all bent into a ball, and the guy on the wrecker says the car did its job.
That's right. That is.
Because I was still
right.
walking. What did we miss?
I mean,
What were we supposed to talk about? Anything else?
shoot. I mean, ways to get in touch with Dan?
No,
maybe?
everybody knows how to do that. How about, no, go ahead and pitch Bill's company.
Sure.
So if you need cladding,
Yeah, if you need any type of equipment weld overlaid or corrosion resistant from the inside out, or need some level of fabrication support around your complex designs, we are happy to throw our hat in the ring and give
Who
you
are
guys
you?
a square shot. I am Superior Cladding and Fabricating Specialties.
right here in Houston, Texas.
That is
you have
right.
a website.
Yes, we do. That's scphou.com. It's stuck in the 90s, but you can still reach us from there in that regard. And we're also on LinkedIn. And you can reach us from a phone number at 281-405-9400. And if you want to look for quotes like up front, quotes@sephou.com.
You're one of the guys I send work to, and you've never let me down.
I do my darndest to do a good job.
All right, okay, go off, don't get hurt, come back and give us a full report.
Yep, I would wish if you came and watched.
Hey, I'm going to try to crew for you.
That would be even better, yeah. The Ultra 4 guy is going to pit as well, so we're
Excellent,
stoked.
excellent. All right,
Yeah.
well, I'll try to make it there. Thanks for coming on today. Let's get you back.
Thanks for having me, Dan. Appreciate it.